second semester review for the final exam. Let's see if we can do this in less than an hour. Okay, the graphing calculator portion. Make sure your calculator is in radian mode. Number one, solve an equation. Now, how do you solve any equation? Well, you make one side 0, and you graph. So basically, you graph this on your calculator, see where it crosses the x-axis. Those are your answers. Number two, using the power series for e to the x, here, let's write this out. E to the box is equal to 1 plus box squared over 2 factorial plus box cubed over 3 factorial plus so forth. What is the least number of terms needed to approximate 1 over radical e so that the magnitude of error is less than 10 to the negative 5? Okay, so 1 over radical e, isn't that e to the negative half? So what we're doing is we're plugging in negative half for box. And we want to find the first term that's less than 1 over 100,000. So what you do is on your calculator, looks like it's going to be out here somewhere, compute each of these. The first number that's less than 1 over 100,000. So let's say, well, what's the answer here? Because I don't have a calculator with me. The answer is, oh, it's over there on the bottom, 7. So the 8th term, what's the 8th term going to be? So that number is less than 1 over 100,000. So that means everything before it. And that's going to be 7 terms then. So that's Leibniz's theorem. Notice that it is an alternating series. Okay, number 3. Solve the following system. We got 5 equations, 5 variables. So in matrix A on your calculator, matrix A, you put all the coefficients. So 1, 1, negative 1, 1, negative 1. 1, negative 1, 1, 1, negative 1. 1, 1, 1, negative 1, negative 2. 1, negative 2, 1, negative 1, negative 1. 2, negative 1, negative 1, 1, negative 1. Put that in matrix A. Matrix B, you put the constants. 3, 7, 9, negative 3, 0. And if you want to find the solution to the system, all you do on your calculator is go A inverse times B, and boom, that's going to be the answer. Number 4, on the birth of the sun, okay, so this is a recursive sequence. So the first term is going to be 2,500. And an account paying 6% per year. So what do you do to the previous term? You multiply by 1.06, right? Because it grows 6%. And then you also invest $1,000 more, like that. Okay. Find the amount on the 18th birthday. So all you have to do basically is find the 19th term of this sequence. So you either can put it in the table, right, using sequences, or, well, like I told you, use the answer button, which is a lot faster, I think. So what you do first is you punch in 2,500 on your calculator, enter it, and then using the answer button, you punch in 1.06 times answer plus 1,000. Go to the 19th term, boom, that's your answer. Because remember, the first term is when the person is born, right? So that's why we want to find the 19th term. Okay, how do you compute a limit on your calculator? Correct the 3 decimal places? Well, again, in order for a limit to exist, it has to approach the same thing from the left and the right, right? And if the left-hand limit and the right-hand limit are the same, that's the limit. So we have to check from both the left and the right. So what I would suggest is punch this in. I guess you would punch it in like this, right? 5 raised to the x minus 1 divided by x. And then plug in a number very close to 0 on the left and then the right. And if they're the same, that's the limit. If they're different, the limit doesn't exist. So what you do is you plug in negative 0.000001. And then you punch in 0.000001. See, what this does is it plugs these numbers into that function if you have it defined on your calculator, right? Or you could just punch it in like this, it doesn't matter. This is a lot faster, I think. And then they should come out to the same number in this problem. So what was the answer for this? 1.609? So this would be the left-hand limit. This would be the right-hand limit. Since they're the same, that's the limit. That's why you have to check from both the left and the right. Okay, number 6. We have a function here. Okay. For what values of x is the derivative less than 0? So first thing you gotta do is you gotta take the derivative. So the derivative of e to the x is e to the x. The derivative of cosine is negative sine minus 2x. When is this less than 0? You have to do this a lot in calculus. So how do you solve any inequality? You make one side zeros, which it is. You graph this on your calculator, and then you look where is the graph below the x-axis. I think we can handle that. Part B. When is the first derivative equal to the second derivative? Well, if this is the first derivative, now we need to compute the second derivative, which is going to be e to the x minus cosine x minus 2. So when will these two be equal? So equal. How do you solve any equation on your calculator? You make one side 0. So on your calculator, this is what you graph. Negative sine x plus cosine x minus 2x plus 2. And see where it crosses the x-axis. Number 7. Given the points, so what you have to do is go into stat mode, right? And input L1 and L2. Remember, L1 is x and L2 is y. So 2, 1, 3, 2. I'm just telling you what to do. If you kind of forget how to do it, then you got to go back to the notes and look. Oh, I see prime numbers on the left. I see Fibonacci numbers on the right. Write the equation of the best fit straight line. So once you punch these in on your calculator, then you go to linear regression to compute the best fit straight line. I think you guys can handle that. Okay, number 8. 1 times 1 times 1 plus 2 times 3 times 4 plus 3 times, we did this, plus dot dot dot, all the way until 50 times 99 times 148. So first you got to write this in sigma notation, n equal 1 to 50, right? There's 50 terms. Now how do you generate the numbers 1, 2, 3? That would be n. How do you generate the numbers 1, 3, 5? That would be 2n minus 1. And then how do you generate the numbers 1, 4, 7? That would be 3n minus 2. Multiply this out, so that would be what? 6n cubed minus 7n squared plus 2n. Did I do that correctly? Then you separate it into separate sigmas, so that would be 6n cubed, and then you can put the constant on the outside, minus sigma, n equal 1 to 50 of 7n squared, or you can put the 7 on the outside, plus sigma, n equal 1 to 50 of 2n, but you can put 2 on the outside. And then this thing right there, what does that mean? That means 1 cubed plus 2 cubed plus 3 cubed all the way to 50 cubed. We have a formula for that, right? 50 times 51 all over 2 quantity squared minus 7 times, and this thing there, 1 squared plus 2 squared plus 3 squared all the way to 50 squared. Hey, use some body, yeah? 50 times 51 times 101 all over 6. We still gotta know those formulas? Duh. And then this thing there, 2 times 1 plus 2 plus 3 all the way to 50, that'll be 50 times 51 all over 2. And then since you have a calculator, you punch that in and that's your answer. Number 9, parametric equations. Graph this, and then again, you're going to draw graphs on the back of your answer sheet. So all you got to do is go to parametric mode, and again, you should be in radian mode. Punch this in on your calculator, and then whatever you see, draw it on the back of your answer sheet. I'm not sure what that is. Probably looks something pretty though. Okay, now the non-calculator portion. Now remember, the calculator portion, the problems are 2 points each. And then now, no calculator section, every problem is 1 point each. Okay, find the focus of the parabola y plus 3 squared equal 8 times x minus 2. Okay, so it's already in standard form, right? So since the y is squared, that means it opens either left or right, and since This number here is 4p, so p is equal to 2. And so since p is positive, that means it's opening to the right. Here's the vertex. The vertex is going to be 2, -3. So the focus is inside here, right? So p is the distance from the vertex to the focus, or from the vertex to the directrix. But in this problem, we're just trying to find the focus. So all you have to do is go 2 units to the right. So wouldn't that be 4, -3? Yes. Number 2, write the equation of the hyperbola in standard form with foci. Okay, let's draw this. 1, -2. These are the foci now. And 1, 6. So shouldn't the center be halfway in between? Yeah, that would be 1, 2, using the midpoint formula. Okay, we got the center. We can write almost the whole equation already. So since this is going to be an up and down hyperbola, since the foci are up here, the y is going to come first. So y minus 2 squared over a squared minus x minus 1 squared over b squared equals 1. Minus because it's a hyperbola, plus if it's an ellipse. And eccentricity 2. And of course, eccentricity is c over a, so we know c over a is 2. Well, the distance from the center to the focus, that's what c is, so we know c is 4 already. And now that c is 4, we can figure out a gotta be 2, right? Since c over a is 2, and so therefore this gotta be 4, right? Because that's a squared. And once you know a and c, how do you figure out b squared? Or b? What's the equation you gotta know for the hyperbola? C squared equals a squared plus b squared. So therefore, c squared 16 is equal to a squared 4 plus b squared. That means b squared gotta be 12, and then you're done. Okay, where are we? Number 3. Find the eccentricity of this ellipse. So we gotta complete this square. So put all the x's together. And then you can, on the y's, you can factor out the 3, so you're gonna have y squared minus 6y equal -7. Put the constant on the other side. So now we complete the square. So what do I need to add to make a perfect square? 4. And then y squared minus 6y plus 9 equals -7. But remember, you added a 4 over here and you added a 27 over there. So that's going to come out to x plus 2 quantity squared plus 3 times y minus 3 quantity squared equals 24. And we want this side to be 1, so divide by 24 plus, and there you go. So remember, the bigger number is the a squared for the ellipse, and the smaller number is the b squared. And what are we trying to find here? We're trying to find the eccentricity, which is c over a. Well, that should be pretty simple, because if a squared is 24, a is going to be, what, 2 root 6? How do you figure out c? Well, in an ellipse, c squared is equal to a squared minus b squared. So that's going to equal 24 minus 8, which is 16, which means c is 4. So you got that. So the eccentricity is then going to be 2 over root 6. Okay, next we got vectors. Okay, what do we got here? Number 4. Vector v is equal to 2 root 2, -2, -6. Find the angle v makes with the positive z-axis when the tail is placed at the origin. Okay, just to give you a feel of this problem. Now this isn't correct, correct because the y and the z components are negative, but I'm just showing you what's happening here. So we have a vector v like this. Anytime we want to find the angle it makes with the positive z-axis here, let's call that theta. Now remember, anytime you're trying to find angles in 3 dimensions, you want to use the dot product, right? So all you got to do is, think of a vector that points in the positive z direction. Well, I'm thinking 0, 0, 1, or how about 0, 0, 2, or 0, 0, 3. But we just go with 0, 0, 1. Any vector is fine. And how do you find the angle between 2 vectors? You use the dot product thing. So cosine theta is equal to the dot product of the 2 vectors. Now, remember how to find the dot product? You multiply the x components, you multiply the y components, that's 0, and then you multiply the z components, right? Add them up. and then you divide by the length of this vector, which is the square root of this squared plus this squared plus this squared, which is 1, and then the length of this vector, which is the square root of that squared plus that squared plus that squared. So that's going to be, 8 plus 4 plus 36, which is root 48. So this simplifies, well, since this is the no calculator section, it's got to simplify to something pretty nice, you would think. And then what is root 48? Quick! 4 root 3, and this can simplify to negative 3 over 2 root 3, which is negative root 3 over 2. Hey, you somebody! Cosine of what angle is negative root 3 over 2? That would be 5 pi over 6, or 150 degrees. I'll take radians or degrees. Number 5. Write the equation of the plane. Now, what do you need to write an equation of a plane? You need a perpendicular vector, we call that n for normal vector, and a point. Those are the two things you need to write an equation of a plane. So, it passes through these 3 points. Okay, why don't we label them? A is, we don't even need to draw 3, 1, 4. B is 1, 5, 9. These look like the digits of pi for some strange reason. Okay, that's because I wrote it. Okay, so these 3 points lie in the plane. How the heck do you find a vector perpendicular to that? Well, duh, the cross product, right? Because the cross product is a vector perpendicular to the plane containing those 2 vectors according to the right-hand rule, right? So what you do is you form any 2 vectors from these 3 points. So how about AB and AC? So you componentize them, and remember, you got to go head minus tail. So 1 minus 3, 5 minus 1, 9 minus 4. And then for AC, again, head minus tail. 2 minus 3, 6 minus 1, 5 minus 4. So these 2 vectors lie in the plane that you're trying to find. So just compute the cross product. So you make a determinant, I, j, k, 2, 4, put the components in, and then compute this. So I like to go across the first row, so it's going to be I times, cross out the row and column that it's in, right? So what is that? 4 minus 25, negative 21. Minus j, don't forget the plus minus plus thing. So cross out the row and column that it's in, and you're going to get negative 2 plus 5, which is 3. And then plus k times, cross out the row and column that it's in, negative 10 plus 4 is negative 6. And again, if you don't like the IJK notation, just change it back to this. So this is the cross product. It's a vector that's perpendicular to the plane. And that's what we want. So therefore, this vector that's perpendicular is negative 21, negative 3, negative 6. Now if you want to reduce that vector, you can. You can reduce by 3 or negative 3. Well, what the heck? Well, why don't we just leave it? Okay? So since this vector is perpendicular to this plane, the equation of the plane is going to be negative 21x minus 3y minus 6z plus d equals 0. And how do we figure out what d is? You plug in any one of these 3 points, any point that's on the plane. And that will figure out d, and again, don't forget you have to write your answer in simplest form, so then you need to reduce that down. Okay, oh, 1 page already. Okay, number 6. Well, this one we're just using what we did in the last problem. Find the, now, these bars mean the magnitude now. Okay, so first, how do you compute V1 cross V2? You make a 3 by 3 determinant. Okay, so since V1 comes first, you put the components in, and then the V2 components next, and then you compute that. So again, I like to go across the first row. Don't forget the plus minus plus. So crossing out the row and column for I, you get, what's that, 4 minus 6. J, cross out the row and column, so that's 2 minus 8. And then the K, cross out the row and column, 3 minus 8 is negative 5. So again, if you don't like IJK, then do this. But then it says to find the length of it. How do you find the length of a three-dimensional vector? It's the square root of this squared plus that squared plus that squared. So what does that come out to? That comes out to root 65. And there you go. The bars means the magnitude of the vector. What problem are we on? Say what, girlfriend? Oh, we're in number 7 now. Okay, graph each pair of parametric equations over the given interval of t. No calculator now, so you're going to be drawing this on the back of your answer sheet. So A, x equals sine squared t, y equal negative cosine squared t from 0 to 2 pi. Probably the most important step is to eliminate the parameter here. So, since these are squared already, line them up, and what do I need to do to use an identity? You subtract, so you get x minus y equals 1, right? Because sine squared plus cosine squared is 1. That's a line. So what you do is you graph this line. So the x-intercept is 1, the y-intercept is negative 1, so... Now how does the particle travel on this line? Well, what you need to do is you need to make a chart. Hopefully maybe you can do this in your head, but if you need to draw it out. So 0 to 2 pi, I probably would say all the quadrantal angles would be good enough. Okay, so if you plug in 0, you're going to get, go back to the original equations now. 0, 1. If you plug in pi over 2, you can get 1, 0. You plug in pi, you can get 0, negative 1. And then you plug in 3 pi over 2, you can get 1, 0. And then if you plug in 2 pi, you can get 0, negative 1. Oh, I think I made a mistake on that. That's negative 1. Woo! Okay, so what happens? The particle starts at the point 0, negative 1. Then it goes to the point 1, 0. Then it goes to the point 0, negative 1. Then it goes to 1, 0, and then 0, negative 1. So it goes hee-haw, hee-haw. So then that's what you draw on the back of your answer sheet. No real tricks there. B. X equal 2 tangent t, y equals secant squared t, t goes from 0 to pi. Oh, looks like we're going to have a hyperspace situation here. Okay, so tangent, when you see tangent and secant, you're going to use the identity tangent squared plus 1 equals secant squared. So first equation, isolate the tangent, and then square both sides. Right? And then this equation, oh, we should have wrote it the other way, just to save time. So x over 2 equal tangent t, then you square both of them. And then this one, secant is already squared, so you leave it, and then you line them up, because secant squared minus tangent squared is 1. So this minus this, y minus x squared over 4 is equal to 1. See, secant squared minus tangent squared is 1. And there you go, that's your rectangular equation, which is y equal x squared over 4 plus 1. That's a parabola. So this is a parabola shifted 1 unit down. And it's opening up. Oh, what am I saying 1 unit down? Duh, it's 1 unit up. That's what happens when it's too early in the morning. And it's kind of wider, so it looks like that. Okay, and so let's make a chart here. Darn it. I just try and squeeze it in here. So 0, pi over 4, pi over 2, 3 pi over 4, pi. Okay, go back to the original equations and plug in. So 0, 1. Pi over 4, that's going to be 2, root 2 squared is 2. Pi over 2, undefined, undefined. 3 pi over 4, negative 2, 2, root 2 squared, right? Negative root 2 squared is 2. And then finally pi, you're going to get 0, negative 1 squared is 1. So the particle starts here, it goes up to the point 2, 2, and then it explodes out to infinity. So it goes like this. And then it disappears, and then it looks like it's going to reappear over here, and then right? Because of negative, right? Tangent is negative in the second quadrant. So if you plug in something just past pi over 2, tangent is really big negative, and so that's why it's going to reappear over here and then so basically it's the whole graph. I didn't try and trick you or anything on that one. Okay, C. Oh, double angle identity, just when you thought you didn't have to know identities. Okay, so the identity, which identity am I going to use for that? 2 cosine squared minus 1, because that's cosine. So if you just substitute it in, you get y equal to 2x squared minus 1. That's a parabola. Shifted 1 unit down, and the x-intercepts are going to be plus or minus 1 over root 2. So it's kind of like that. Okay, now how is the particle going to move on this? Well, here, let's make the chart again. And since it's going from 0 to 2 pi, I think the quadrantal angles will be sufficient. So you go back to your original equations. If you plug in 0, you get 1, 1. You plug in pi over 2, you get 0, negative 1. You plug in pi, you get negative 1, 1. You plug in 3 pi over 2, you get 0, goes to negative 1, and then you plug in 2 pi, you're going to get 1, 1. So the particle starts at 1, 1, then it goes to 0, negative 1, then it goes to negative 1, 1, then it goes to 0, negative 1, then it goes to 1, 1. So it goes like this. All right. Okay, we're in matrices now. A. If A is equal to this, and B is equal to that, find matrix X. So again, you know, semester exam, you just got to know basic concepts. Okay, so first you got to solve for X. So which side do you want to put the X's on? Left or the right? Like if I were me, I'll put it on the right, but whatever. It doesn't matter. And again, remember with matrices, the commutative property of multiplication doesn't hold. So since the x's are on the right, if you factor out the x, you have to factor it out on the right. And how do you get rid of this here? Divide both sides by b minus a. Don't be ridiculous, because there's no such thing as division in matrices. So you have to multiply by its inverse. But since it's on the left, you got to multiply it on the left. So multiply both sides by b minus a inverse on the left. And there, that's how you solve for x. The commutative property of multiplication does not hold. So all you got to do is find the inverse of b minus a. So first of all, what is b minus a? This minus that. So just subtract the corresponding component. So is 3. 3 minus negative 2 is 5. 2 minus 0 is 2. 1 minus negative 2 is 3. Inverse times b times a. Now, why don't we do this first? Now, you guys remember how to multiply matrices? You have to put the b first and then the a second. So here's b. You put a over here. So when you multiply a 2 by 2 matrix times a 2 by 2, these two numbers have to be the same, which they are, and the resulting matrix is going to be 2 by 2. So there you go, it's 2 by 2. And then, to get this element in the first row and first column, you go across the first row, you come down the first column. The one on the left, you always go across the rows, and the one on the right, you're always coming down the columns. So 4 plus 0, it's 4. So you go, now for this one, you go across the first row, come down the second column. So that would be negative 8 minus 6. And then to get this element here, you go across the second row, come down the first column, so that's 2 plus 0, which is 2. And then over here, go across, come down, that's going to be negative 4 minus 2, which is negative 6. Now we've got to multiply these. Now, how do you find the inverse of a 2 by 2 matrix? You go 1 over the determinant of this, which is this times this minus that times that. So 9 minus 10 is negative 1. You switch these two, they're both the same, and then you negate these two. Negative 5, negative 2. And then we're going to multiply that by 4, negative 14, 2, negative 6. So I don't know what you want to do. You want to put the negative 1 in now, or multiply these two first and then put the negative 1 in? Well, if I were me, I would put the negative in later. So again, same thing. You go across, you come down. So that's 12, and a negative 10 is 2. Negative 42 plus 30. What did I just say? Negative 42 plus 30. That's negative 12, yeah? Go across, come down. Negative 8 plus 6. And then 28 and negative 18. What did I just say? 28 and negative 18 is 10. And then put the negative sign in. So your final answer will be negative 2, 12, 2, negative 10. There you go. Okay, what number are we on now? Number 9. Compute a 3 by 3. Yeah, so you won't be doing 4 by 4 determinants. Okay, so pick any row or any column. What the heck? Let's just go across the first row. So it's going to be 3 times something minus 2 times something plus 1 times something plus minus plus. Cross out the row and column that it's in. So you're going to get 4 minus 9, which is negative 5. Go cross out this row and column. So you're going to get 16 minus 6, which is 10. And then for this one, cross out the row and column. You get 12 minus 2, which is 10. And then you just compute these numbers. Negative 15 minus 20 plus 10. So what is that? Negative 35 plus 10, negative 25. That's an easy one. Okay, let me just make sure the camera's going, so nothing went wrong. I'd be very upset if something went wrong. All right, it's going, it's going. All right. Oh, now we got combinatorics, number 10. How many 4-digit numbers have at least 1 6 in them? So when you hear the phrase at least 1, you want to do the complement, right? What's the complement of at least 1 6? No 6s. And then you subtract that from the total, right? So how many total 4-digit numbers are there? 1, 2, 3, 4. We can use the multiplication principle here. In a 4-digit number, since it's a permutation, we can use this slot method here. How many choices do I have for the first digit if it's a 4-digit number? Anything except the 0. But then now, you can use the 0, so 9, 10, 10, 10. So 9,000. Minus now, how many 4-digit numbers don't have any 6s in them? Well, how many choices do I have for the first digit? Anything except a 0 or a 6, so that's 8. How many choices for the second digit? Anything except the 6, so that would be 999, and then you compute that. I will leave the computation to you. How many 4-person committees? Ooh, committees. So that the order is not important for that, so it's going to be a combination. How many 4-person committees can be selected from 5 men and 6 women if each committee must contain at least 3 women? So what does that mean, at least 3 women? That means you could have 3 women and 1 man, right? Or you could just have 4 women and no man, no men, right? That's what it means. Okay, so how many ways can you select 3 women from the 6? So that would be 6 choose 3, and 1 man from the 5, 5 choose 1, and you multiply them because they're going to be on the committee together. And then same thing with the 4 women, 6 choose 4, and no men, 5 choose 0, but of course 5 choose 0 is 1. And you multiply them because they're going to be on the committee together. If events occur together, you multiply. If they're mutually exclusive, then you add. So these 2 cases cannot occur together, so that's why you add them. And then I'm assuming we can add that. Well, just for a refresher, what's the shortcut to compute 6 choose 4? Well, 6 choose 4 is the same thing as 6 choose 2. Does that sound familiar? And then the shortcut is you take that number, write that number factorial on the bottom, and then since you have 2 here, you make sure you have 2 on the top starting with this number. So it's 6 times 5 over 2 times 1. 2 goes into 6 3 times, so 15. So So this one here will be 15. Of course, that's 1. What the heck, let's just do them all. Anything choose 1 is anything. And how do you compute 6 choose 3? Well, it's going to be 6 times 5 times 4, over 3 times 2 times 1, 20. And I think you can compute that. I'm not sure. 11.5. Now somebody said the answer on the bottom is wrong. Well, it probably is, but here we go. A Locker permutation is made up of 3 downs. It's a permutation now. The order is important, so we can use the multiplication principle here. It's made of 3 downs, each with the letters A through Z. If exactly 2 of the letters are the same, how many permutations are possible? So let's do a specific case, that these 2 are the same. So how many choices do you have here? 26. And this one has to be the same as that one, so that's 1. This one has to be different from the first 2, so you have 25 choices. But is that the only case where the ones that are the same are 1 and 2? No, it could have been 1 and 3, or it could have been 2 and 3. So there's 3 cases. You multiply by the number of cases, and then you multiply that out. 11.7, what the heck is that? How many ways can 3 groups of triplets be seated around a circular table if each group must be seated together? Okay, so here's a circular table. Now, if people have to sit together, you make a bench, right? So, basically, you need 5 benches. Okay, so how many ways can you arrange 3 things around a circular table? Well, the answer is 2 factorial, right? N minus 1 factorial. But on this bench, you got 3 people. How many ways can these 3 people be arranged? 3 factorial, right? And same thing on this bench, 3 factorial. Same thing on that bench, 3 factorial. And then you just multiply it out. Can we squeeze in number 12 here? Well, let's try. 3 cards are randomly drawn from a deck of 52 cards. What's the probability of getting exactly 2 hearts? Well, the denominator is going to be 52 choose 3, right? Yes, because cards, the order is not important, right? This is a probability problem, so there's going to be a denominator here. How many ways, so for the numerator, how many ways can you get exactly 2 hearts? Well, how many hearts are in the deck? 13. So how many ways can you pick 2 of them? 13, choose 2. And then of course the third card is not a heart. So how many cards in the deck are not hearts? 39. How many ways can you select 1? 39, choose 1. And then I guess the hard part for you guys right there, now you got to compute that. A lot of things cancel out though. As you well know. Okay, next. 12.5. 2 4-face dice are tossed. What's the probability that the sum of the 2 rolls is a prime number? We've done this problem so many times. The best way to do the dice problem is write out the sample space like this. What can happen when you roll 2 dice? This is 3-1 full. And then, so there are 16 elements in the sample space, so you know it's going to be something out of 16. So what's the probability that the sum is a prime number? Well, 2, 3, 5, and 7 are prime numbers. So what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 16. 13. A coin is designed so that the probability of tossing a head is 3/4. So that means the probability of tossing a tail is 1/4. If the coin is tossed 4 times, find the probability of getting exactly 2 heads. Well, you can just do this the regular way, or you can use the binomial probability thing that we learned. Okay, so what's the probability of a success? That means tossing a head. Well, it says right there, 3/4. Therefore, the probability of a failure is 1 minus that. Now, when to use binomial probability, that's when you do an experiment with only 2 possible outcomes repeatedly. Okay? So you either toss a head or a tail, right? So success is a head, failure is a tail. How many times are we doing this experiment? It says you're tossing the coin 4 times. And then how many successes do we want? What's the probability of obtaining 2 heads? So we want 2. So using the formula we learned, then the answer is just going to be 4 choose 2 times the probability of a success raised to the 2, which is that, and then the probability of a failure to the 4 minus 2. These two powers got to add up to that. So whatever power you put here, you just got to make sure this plus this equals that. And then you can compute that. Or just do it the way we learned. You don't have to know anything. Do a specific case. You get head, head, tail, tail. What's the probability of getting a head? 3/4, 3/4. Then tail, 1/4, 1/4. But is that the only order you can get 2 heads and 2 tails? No. So how many different orders are there here? Well, that's like a 4-letter word. How many 4-letter words contain 2 H's and 2 T's? Wouldn't that be 4 factorial over, but you got 2 H's and you got 2 T's. But that's the same thing as 4 choose 2. So you get exactly the same thing. Okay, what number are we on now? We got a coin. Oh no, we're done with that. Number 14, expected value. A bag contains 3 blue, 4 red, and 5 green tokens. 2 are randomly drawn. If both are the same color, you win $66. Otherwise, you lose $33. What is your expected value? Okay, so we're going to draw 2. We want same color, but there's 3 ways you can get same color. You can get 2 blues, 2 reds, or 2 greens. So we got to compute the probability of all of those. So if you can think of pulling it out 1 by 1 or 2 at the same time. I'm going to do 2 at the same time. So there's 12 total, so 12 choose 2. Okay. So what's the probability of getting 2 blues? Well, wouldn't that be 3 choose 2? Because there's 3 blues and you only want to select 2. What about 2 reds? 12 choose 2 in the denominator, but since there's 4, it's going to be 4 choose 2. And then what about greens? 12 choose 2 in the denominator, and since there's 5, it's going to be 5 choose 2. And then you add those probabilities together. So this is the probability of getting 2 of the same color, and it says you win $66. So you multiply it by $66. Now, what is the probability of not getting 2 of the same color? Well, whatever number you get here, why don't we call this P? Then wouldn't this be 1 minus P? You subtract it from 1 because it's the complement. That's the probability of not getting 2 of the same color. And then what happens? You lose $33. So you multiply it by negative 33. Compute that number. That is your expected value. That means what are you expected to win every time you play this game? So basically, you just multiply each probability by what you're going to win or lose. And then add them all up. Okay, then we're in sequences now. This is the 4th quarter stuff. Okay, write an explicit formula for this. Okay, so let's see. If it's arithmetic or geometric, then you got formulas, but it's neither, so we have to rely on our mathematical prowess. So one thing you can do is break it down. Like when I see 9, I think 3 times 3, 4 times 5, 5 times 7, 6 times 9, so then 2 times 1 to make it fit the pattern, right? So how do you generate the numbers 2, 3, 4? That would be n plus 1. And then how do you generate the numbers 1, 3, 5? That would be 2n minus 1. And we're done. Now, if you can't do that though, if you have a hard time breaking it down, then you look at the differences. 7, 11, 15, what about that, 19? 4, 4, 4, 4. If it takes 2 levels, that means the formula is going to be quadratic. So 8n squared plus bn plus c. And then you solve 3 equations, 3 variables. If you plug in 1 into this formula, you should get the first term. You plug in 2 into this formula, so what would that be? 4a plus 2b plus c. You get the second term of 9. And if you plug in 3 into that formula, you will get the third term of 20. And then you solve these 3 equations, and you're going to get exactly the same thing as this. But at least if you can't break it down, you have something to rely on. Complete the recursive formula. Okay, so here's the recursive formula. A1 is 2, an equal an minus 1 plus box. So like I told you when we did this, a2 equal a1 plus what? A3 equal A2 plus what? A4 equal A3 plus what? A5 equal A4 plus what? So look at this. This is the sequence. What do I have to add to the first term to get the second term? 7. What do I have to add to the second term to get the third term? 11. What do I have to add to that? 15. And then what do I add to that? 19. And hopefully there'll be a pattern there. Yes, there's a pattern. Look at those numbers. It's arithmetic. The common difference is 4. So you write 4n, and then you adjust it. And again, remember, in a recursive formula, you start by plugging in this. So if you plug in 2, you want to get 7. So 4 times 2 is 8. What do I need to do to 8 to get 7? Minus 1. Oh. Okay, 16. Okay, given the series, oh, this is an infinite series, and it's not geometric, so we're going to find the limit of the sequence of partial sums here. So the first thing it says, find S sub n. That's the formula for the partial sums. So write out the first few terms. Plug in 1. What do you get? 1/3. Plug in 2. 1/15. Plug in 3. What did I just say? 3. 35. Plug in 4. 4 is 63. Okay, now let's look at the partial sums. What's the sum of the first term? What's the sum of the first two? So if you make a least common denominator, that's going to be 6 over 15, which can be reduced to 2/5. What's the sum of the first three terms? Make a least common denominator, and that's going to be 15 over 35, which can be reduced to, I'm recording, 15 over 35, no, I lost my train of thought. 3 over 7, okay, that's probably good enough because this one's simple. So what's the formula for the partial sums here? Well, how do you generate the numbers 1, 2, 3? N. How do you generate the numbers 3, 5, 7? That's 2n plus 1. So that's the formula for the partial sums. And then now, if you want to find the sum of this infinite series, you take the limit as n approaches infinity of that, which is 1/2, right? If the degree of the top and the bottom are the same, you look at the coefficients. So that means if you keep on adding these numbers forever, you will get exactly 1/2. 17. Ooh, we got series here. You guys should be experts at this. Okay, write out the first few terms. 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, plus dot dot dot. What's the only power series that has the consecutive numbers factorial? E to the box, right? So that's 1 plus box squared over 2 factorial, plus dot dot dot. What number do I have to put in the box to generate these numbers? Well, in this case, it's 1, right? Yeah, but Mr. Park, we just want to find this, right? Because this is like 1 over 1 factorial. So what you got to do is just move this to this side, so the answer is just e minus 1. Yeah, you're not going to get really tricky ones on the final exam. Okay, B. Sigma n equal 1 to infinity, 4, 5/7 to the n. Now this is a geometric series because you have a number to the nth power, right? So, if you have an infinite geometric series, remember the formula is a1 over 1